In chapter 3, the sections included are 1, 2, 4, and 5. So 3 and 6 are not included. This video is about section lo3-1 or learning objective 1 in chapter 3. Compute and interpret the mean, the median, and the mode. The mean, the median, and the mode are called measures of location. The purpose of the measure of location is to pinpoint the center of a distribution of data. The mean is just the summation of the numbers in a data set divided by the number of numbers. It can be the population mean indicated by the Greek letter mu, or it could be the sample mean indicated by the letter x bar. The formula is the same, the summation of x divided by n, where sigma is the Greek letter, sigma of course, that indicates the operation of adding. So using a very simple example, if you have a variable x whose values are 3, 7, and 11, the mean in this case is the summation of 3 and 7 and 11 divided by 3, the number of numbers. And you get 21 divided by 3, and that is 7. Okay, so that is the mean. The population mean example shown in the slides is 42 exits on I-75. And those are the distances, between exits, between all the 42 exits on I-75 through the state of Kentucky. And calculate the mean. And this is the case of a population mean because we are considering all the exits, not just a sample. And of course it will be adding all these numbers, as shown here, adding all the numbers, divided by 42, and you get 4.57. Now in Excel, I need to open this again. I have the population example. This is the same these are the same numbers, and all you need to do is just type equal average, open parenthesis, select the data, close parenthesis, hit enter. 4.57 as shown in the slides. Now, when you calculate a mean from the population, it is called a parameter. If you calculate it from a sample, it is called a statistic. And the same applies to whatever else you can measure, like the median, the mode, the variance, the standard deviation, and others. If it is on the population, it is a parameter. From a sample is a statistic. In the slides, the example of the sample mean is Verizon, which is studying the number of minutes used by clients in a particular cell phone rate plan. And they take a random sample of 12 clients, and these are the amount of minutes. What is the mean number of minutes used, or arithmetic mean? Add the numbers divided by 12 gives you 97.5. And again, these are the numbers here, the 12 numbers. In Excel, you just type equal average, open parenthesis, select your data, close parenthesis, 97.5. And let me go back. Properties of the mean or characteristic. And one that I want you to, well, all values are used, it is unique, there are not two means. But the one that I want you to pay special attention is that the sum of the deviations from the mean is 0. And that is illustrated, or can be illustrated with this particular example. If you take each value from the variable x and you subtract the mean, so you take 3 minus 7, okay, and add the next number minus, again, the mean, 7, and then add the final, 11 minus 7. Then you get minus 4 plus 0 plus 4, and that is equal to 0. So that is a characteristic of a mean. It doesn't matter how big the sample or how small the data set is, you get the same result. Now another measure of location is, excuse me, the median. The median is the midpoint of the values after they have been ordered from the minimum to the maximum value. Okay? There is a unique median always. It is not affected by extremely large or small values. And forget about the ratio level, interval level, ordinal level data. You can read that in chapter, I believe it's 1. But the data that we're going to use most of the time is ratio level, or what you find in all typical numbers like your weight, your height, sales from a company, etc. Interval scale is values like bands that are from 38 through 40, from 42, 46, etc. And ordinal level is when you have 1, 2, 3, 4. And 1, 2, 3, 4 indicate order. Okay? Indicate first is number 1, second is number 2, etc. But we are not going to emphasize this in this class. This is an example of a data set, 5 numbers, 21, 25, 19, 20, 22. Then if we arrange them in ascending order, we get 19, 20, 21, 22, 25. And the median is just the value in the middle of the distribution. Notice that you'll find 2 numbers to the right, 2 numbers to the left. But that is easy to find when the number of numbers is odd. However, when you have an even number of numbers, it is not as obvious. You can always find the location of the median by using the formula n plus 1 divided by 2. So if I have 5, where n is the number of numbers, so if I have 5 numbers, 5 plus 1 will be 6, and then divided by 2 gives me 3. So the position of the median is position 3. 1, 2, 3, what 21 is. Now in this case, 76, 73, 80, and 75, if you place them in ascending order, you get 73, 75, 76, and 80. The median is in position 2.5. If you use the formula, it'll be 4 numbers plus 1 divided by 2, give you 2.5. In position 2.5 is between 75 and 76. And between 75 and 76, you calculate the average of the two, you find the value 75.5, that will be an approximation for the median. Now in Excel, you calculate the median by just typing equal median. Open parenthesis, then select the data, then close parenthesis, click enter, and notice that the value is 3. And here you can do the same. Select the data, and the value is 93. Please notice that the median, 3 here, is less than the average or mean, 4.57. Same here, the median is 93, and the average is 97.5. They are not equal. And there is a reason for that. And that reason is shown here in these 3 charts. Data may be positively skewed, as shown here, negatively skewed on this chart, or symmetric, no skewness. In this case here of the exits in Kentucky, if you notice, the mean is higher than the median. When that happens, there is positive skewness, such as this case. Very large numbers, like this one's here, occur at the low frequency. For example, the salary distribution of a professional sports team, like a basketball team or baseball team. You find a few players who make millions and millions of dollars, but then most of the players make much less than that. So in that case, if you calculate the average of all players, the mean is going to be higher than the median. The median is always going to be in the middle, but the mean is going to be pulled up by the high numbers. And in our little example here, we can see that if we have, for example, 3, 7, and 20 instead of 3, 7, and 11. So the mean is going to be 3 plus 7 plus 20 divided by 3. That gives you 30 divided by 3, and that is 10. Notice that the average will be higher this time, and the average was 7 before. Now it is 10, influenced by this large number. But if you look at the median, the value in the middle still is the same. Still it is the same, 7. Okay. Now you can also have the other extreme. For example, 1, 7, and 11. In this case, the average is going to go down, and the median still the same. Because if we calculate the average this time, it's going to be pulled down by this 1 here, and now we're not going to have a whole number here. This is 18, 19 divided by 3, okay, which is 6 point something. 33. So it's going to be less than this 7 that we had before because it's influenced by the 1. So in this case we have negative skewness. In this case here we have positive skewness. Or skewed to the right in this case, and skewed to the left in this case, and no skewness in this case. Now the final measure of location, or central location, is the mode. Is a value that occurs more often. And if you have a graph where you have the variable being measured on the horizontal axis and the frequency of occurrence on the vertical axis, then it is easy to identify the mode because it is the category that has the highest frequency. In the case of the exits, 1 mile is the one that has the highest frequency, and which is 8, and then the other ones here. Now, if we go to Excel here, you can calculate the mode too. You can type equal mode, open parentheses, and again select the data, close parentheses, and here at the bottom you see it is 1. And in this data set, in the case of the sample, you can type mode, close parentheses, and notice that it says NA because we don't have a mode. Okay, there is no value that is repeated more than 1 time. Okay, so that's the end of my presentation for all my coverage of Learning Objective 3.1. If you have any questions, please do not hesitate to contact me.